Hey there, it's Alana, and we're going to be lecturing on 5.2 for Math 133. This is going to be the addition rule and complements. All right, so let's see how it goes. So the beauty of using events rather than elementary outcomes is that we can combine events. You can mix and match and make something bigger using logical operations. So if you've ever taken a logic class, some of this is going to look a little familiar. The relevant words are and, or, and not. All right, so given events E and F, we can make new events, E and F, E or F, or not E at all. And we're going to have to deal with all three of these and their relative cases as we go. All right, so first of all, let's talk about an experiment. So we're going to roll a fair 10-sided die. E is rolling an even number. F is rolling the number 7 or 9. We're going to draw the sample size in a Venn diagram. Now, I already started you off here. The big box represents the sample size. Over here is event E. Over here is event F. Now, I'm going to insert into this a text box. If I can find it. There it is. Yeah, that's fine. Okay, so what events are E? E is an even number, so that would be 0, 2, 4, 6, 8. I think this was rolling a 10-sided die. Oh, hold on. Just one second. It occurs to me you might want to know what a 10-sided die actually looks like. There's one. There he is. Isn't he cute? If you just do Google Images, which is what all I did, Google Images for 10-sided dice, and let's see what I got. I got them all over the place. That's a 20-sided die. These are 10-siders right here. And 10-siders here, you can see it in this picture right here. 10-siders have a side that says 0 on it, okay? And 0 is an even number, okay? So over at in the example, let me get the notes back up. There. All right, so 0 is even, 2 is even, 4, 6, and 8, okay? There is no 10 on a 10-sided die. I know it's a little strange, but that's just how they work. All right, so let me copy and paste. All right, so over in F, event F is rolling a 7 or a 9. So the only numbers that are in F are 7 and 9. All right, now what does that leave us for the exterior? Out floating around in the sample space ether, if you will, are all the numbers that aren't in either E or F. So that would be 1, 3, and 5. All right, technically these aren't supposed to have boxes. Hold on one second. All right, I accidentally talked without having you listen. Sorry about that. So I made the little boxes disappear. And then it said, what is the probability of E? Okay, the probability of E is 5 out of 10, because there's 5 options here out of the 10 total. What's the probability of F? Well, that's 2 out of 10, because there's 2 over here on the F side out of 10 total. What's the probability of E or F? Well, there's 7 of them, right? Altogether, there's 5 on the left side, left circle, 2 on the right circle. Together, that makes 7, or 0.7. What's the probability of E and F? Well, E and F would be where they overlap, but there is no overlap, right? So that probability there is 0. There is nothing that is both even and a 7 and a 9. Or by the same token, you can't be 7 and 9 and be even. Which means E and F, those events, are something special called disjoint. Disjoint or mutually exclusive is the other word for it. It means that once event E is there, then you can't have event F and vice versa, right? That they have nothing in common. They don't overlap at all. The addition rule for that says if you have events that are E and F that are disjoint, aka mutually exclusive, then the probability of E or F is equal to the probability of E plus the probability of F. Now, for the sake of our poker cards, what's the probability of a king? Oopsie. Probability of king or queen. That's the probability of a king plus the probability of a queen, because once you have a king, you can't have a queen, and vice versa. They're mutually exclusive. They're disjoint. Well, the chances of a king is 4 out of 52. The chances of a queen is 4 out of 52, which means altogether it's 8 out of 52. And you can find what that decimal is with Excel or your calculator. All right, we're done with that one. I'll be back for the next example. See you then.